Exponential functions, a topic not only used in mathematics, but also very applicable to real life. We usually tackle situations like growth and decay. For example, population growth or radioactive decay, or even the spread of viruses. But for this topic, we're going to be using it for the growth of a fashion account, using this model here. So what do you know about this model? First, it's in the form of fx equals b raised to the power of x. Like here. And one of the characteristics is the domain is negative infinity and infinity, and the range is 0 and infinity. So this means the domain is all real numbers, while range is all positive numbers. Now let's talk about its intercepts. As you can see, the graph never intersects the x-axis because there isn't any x-intercept since there is no negative time, and since the range is 0 into infinity. So meaning, to get the y-intercept, since there is no x-intercept, we need to replace t with 0, and then after computing it, it'll become 1000. Let's move on to the asymptotes. As you can see here, the graph of fx equals b squared to x, like this model we have here, approaches but does not touch the x-axis, or y equals 0, because that is the horizontal asymptote. You may be wondering, what about the vertical asymptote, like the one here? There. It doesn't touch because it's defined for all values of x, meaning there is no x-intercept. Point may be looking for the logarithmic form, which is here. Since it is its inverse, logarithmic is the inverse of exponential and vice versa, it will make sense that everything that was an exponential function would be inverse logarithmic, like this. Of its further, it looked like this, and graphically, it will look like this. So let's check the inverse if we got it right. So let's check it. We have two ways. First, if we get x as the answer, like this, it means we're right. And to show you, we are correct with finding the inverse of the original. Let's talk about what's domain and range, which is here. There isn't any horizontal asymptote as shown in the graph, which I'll show you again. Here. That means the HA, but since the inverse, now it's going to be y, is going to be 0 since it's touching all of x. And the x, which is switched now to y, to solve for that, we just do the same thing we did to find the x of the exponential version, which is t equals 0, after some calculations, which I'll show you again, is now equal to 1000. So to sum everything up, we've explored exponential functions, its domain and range, asymptotes, and even the inverse and all of its properties. So there. Thank you for listening.